Ring seals and bearded seals provide food for a lot of people living in the Arctic, but climate change is impacting their health and abundance. In fact, climate change is disproportionately affecting the Arctic, with air temperatures increasing at more than 4 times the global rate. This is causing drastic declines in sea ice, and seals need sea ice to survive. Not only because they use it as a platform to rest, but because sea ice is home to sea ice algae, which forms the base of the Arctic marine ecosystem, upon which all other species rely. In other words, the base of the Arctic marine food web upon which all other species rely. In other words, declines in sea ice are impacting food availability in the Arctic marine ecosystem. But we can study the overall health of this ecosystem by studying species that are long-lived and near the top of the food web, like ring seals and bearded seals. And because these seals live a long time, they accumulate mercury, a potent neurotoxin, in their tissue over time. My research aims to understand the impacts of climate change on ring seals and bearded seals by studying their diet and mercury exposure. Now, traditionally, diet has been studied by looking directly at an animal's stomach contents. The problem here is that it's lethal, and you can only see the last few meals that they ate. What if I told you there's a way to look back in time to see what an animal ate and how they changed their diet over the course of their life and how they tolerated changes in sea ice? I'm using an approach that allows me to do just that. I'm measuring stable isotopes and mercury in individual growth layers in seal claws that were collected during subsistence harvests across Nunavut. Stable isotopes are just naturally occurring elements, and the ratio of heavy to light isotope in an animal's tissue can tell us what they ate when the tissue was grown. So claws are actually an archive of biological information because, like rings on a tree, they have light and dark bands that together represent 1 year of growth. Some claws have as many as 13 bands. So if a seal was harvested in 2020, I can get information back to 2008. Which means that unlike the traditional methods, I can describe changes in diet over the course of the seal's lifetime, compare that between individuals, and see how this varies across the Arctic. What I've found so far is that there actually is a lot of variation between seals because, kind of like humans, they have individual preferences. I'm also finding that the seals harvested more recently have higher mercury levels in their tissue. My research can help us understand how these seals are changing their diet so that we can better mitigate the impacts of climate change on them. Because ring seals and bearded seals provide food for a lot of people living in the Arctic. And if we take care of our planet, we can ensure they remain healthy and abundant into the future. Thank you.